Alpha decay or alpha decay is a type of radioactive decay in which an atomic nucleus emits an alpha particle, helium nucleus, and thereby transforms or decays into a different atomic nucleus, with a mass number that is reduced by 4 and an atomic number that is reduced by 2. An alpha particle is identical to the nucleus of a helium-4 atom, which consists of 2 protons and 2 neutrons. It has a charge of +2e and a mass of 4u. For example, uranium-238 decays to form thorium-234. While alpha particles have a charge +2e, this is not usually shown because a nuclear equation describes a nuclear reaction without considering the electrons, a convention that does not imply that the nuclei necessarily occur in neutral atoms. Alpha decay typically occurs in the heaviest nucleides. Theoretically, it can occur only in nuclei somewhat heavier than nickel, element 28, where the overall binding energy per nucleon is no longer a maximum and the nucleides are therefore unstable towards spontaneous fission-type processes. In practice, this mode of decay has only been observed in nucleides considerably heavier than nickel, with the lightest known alpha emitters being the lightest isotopes, mass numbers 104 to 109, of tellurium, element 52. Exceptionally, however, beryllium-8 decays to 2 alpha particles. Alpha decay is by far the most common form of cluster decay, where the parent atom ejects a defined daughter collection of nucleons, leaving another defined product behind. It is the most common form because of the combined extremely high nuclear binding energy and relatively small mass of the alpha particle. Like other cluster decays, alpha decay is fundamentally a quantum tunneling process. Unlike beta decay, it is governed by the interplay between both the strong nuclear force and the electromagnetic force. Alpha particles have a typical kinetic energy of 5 MeV, or 0.13% of their total energy, 110 TJ/kg, and have a speed of about 15 million meters per second, or 5% of the speed of light. There is surprisingly small variation around this energy, due to the strong dependence of the half-life of this process on the energy produced. Because of their relatively large mass, the electric charge of +2e and relatively low velocity, alpha particles are very likely to interact with other atoms and lose their energy, and their forward motion can be stopped by a few centimeters of air. Approximately 99% of the helium produced on Earth is the result of the alpha decay of underground deposits of minerals containing uranium or thorium. The helium is brought to the surface as a byproduct of natural gas production.